Next, we move on to the mechanical calculation for distillation column. So from the question, first and foremost, you need to calculate the minimum wall thickness for pressure loading. And for design pressure, take as 10% above the operating pressure. You need to insert the operating pressure, which is you can get from the sizing, 1 bar, and you will get the design pressure 1.1 Newton per millimeter squared. And from there, you can calculate the minimum thickness required for pressure loading. And before that, you need to insert the column diameter from the sizing as well, and design stress from the question, and you will get the minimum thickness required, which is 6.73 millimeter. Much thicker wall will be needed at the column base to withstand the wind and dead weight loads. As a first trial, divide the column into 5 sections with the thickness increasing by 2 millimeter per section. This means that you need to compare your column diameter or per cell diameter is the same, and also the minimum thickness weight at the table. And for an example here, the column diameter is 1.64, which it is in between 1 to 2, and the minimum thickness is 6.73, or in the range of 7, where we can assume it to be 7. And you need to round off your answer or values get from the table to even number and put it in the orange color style here. So here we made it 5 sections, and each section we added 2 millimeter of thickness. Then second, you need to calculate the dead weight of the cell using this equation. First, take CV vessel with plates 1.15, and you need to insert the column diameter, same like the sizing before, which is 1.64, and from there you can get the column diameter including the thickness, where you will be using the average thickness for weight. And you also need to insert height of distillation column from the sizing, and then you can calculate the weight of the cell using the formula, and you will get 177 kilonewton. Next, weight of plate. You can calculate the plate area using this equation, and you will get 2.12, and weight of plate 1.2 times plate area, you will get 2.55, and you are required to insert the number of plate or trees from the sizing, and you will get the total number of weight of plates, which is 114 kilonewton. After that, you need to calculate the weight of insulation by inserting the density of insulation material. From the question, it stated that the material is mineral wool, so 130, and insert the thickness of insulation given, which is 75, and we will use the thickness of insulation to calculate the approximate volume of insulation using this formula. And from that, you can calculate the weight using the volume of insulation and also the density of insulation material. So to allow the fittings, you are required to double the weight into 31 kilonewton, and you can calculate the total weight of weight cell, weight plates, and weight insulation, which is 300 to 22 kilonewton. And next, we are required to calculate the wind loading. You have to assume the dynamic wind pressure. However, in this question, it was given that the wind pressure is 1,280. And from that, you can calculate the mean diameter, including the insulation, loading per linear meter using this equation, and bending moment at the bottom tension line using this equation. After that, you are required also to calculate the analysis of stress. These include the pressure stress, sigma H, sigma L, using this equation, dead weight stress, using this equation, bending stress, using this equation, and also this equation. And also from that, you can get the resultant longitudinal stress, which is this equation, upwind and also downwind. The greatest difference between the principal stress will be on the downwind side, which is 58.69. And lastly, you are required to calculate the elastic stability using this equation. That's all from me. Thank you.